Hi guys, so today I'm going to teach you a new lesson about function transformations. This is a super important lesson. It's kind of confusing, but it's super important that you're watching this video and following each step. Okay, so what function transformation really means is our shifting or stretching or we're moving our graph somewhere somehow. Okay, so my first shift is, let me undo that. Sorry about that. I got used to using this. Okay, so my first transformation is a vertical translation up. So what a vertical translation up means is that the whole graph is shifting up. Okay, so it's a shift up. Now, what does this look like? To know when we are going to do a vertical shift up or a vertical translation, we kind of interchange those words. We need to look for an adding sign outside of a grouping symbol, okay? And a grouping symbol, all a grouping symbol is the use of parentheses. So if we have something in our parentheses, then whatever we're looking for outside, okay? So we're gonna look for a plus outside the grouping symbol. Now, using function notation. So f of x, this just means our OG function, okay? So our original function. Here is our plus up, right? So that's important to remember. So we see a plus sign, that means we're shifting up, okay? Now, my transformation rule. So when we are vertical shifting up, we're only, this is super important, only affecting our y coordinates, okay? We are not touching our x coordinates when it comes to vertical shift up or a vertical translation, okay? So we're going to show you an example here. So, example. So my parent function is my original function, okay? It's also important to know here that this is what my parent function looks like. So if you did do that worksheet from when you were in class or if you were learning online, that's important to remember, okay? So that is what that graph looks like. So this parent function is f of x equals x squared, which is a quadratic function. So remember, that's what that looks like, okay? Then we are going to do our transformation. So now we have our transformation function. Now, what we said here, we can really pretend that there is parentheses here, okay? So remember, we are looking for the adding outside of our grouping symbol. So this is important because we have a plus 2 outside of our grouping symbol, okay? So here is now, this is my original, so my parent function graph. Okay, this is the original function. So, like we said here, that's my original function. So, what I want you to do is I want you to pick 3 points that are exactly on a point, right? So we can find the coordinates exact. Okay, so I'm going to go left from right. So my parent function. So let's do this. Parent function. My coordinates are -1, 1. 0, 0, and then 1, 1. Now, every time we do a transformation, whether it's up, down, side, right, whatever we're doing, I always want you to write coordinates first. It's always important to pick 3 or more, okay? So always pick 3 or more coordinates that we're going to change, okay? So now, what I need to do is I need to find my points for my transformation function. So down here, I'm going to put TF, okay? Now, what we're doing is we are adding 2. This is my transformation rule. So, okay, this is what the rule will look like, but this is my transformation rule for this example. So it's y plus 2. So that means what we're going to do is we are not touching any of our x coordinates, right? So that -1 is going to stay the same. But then we are going to add 2 to 1. So this becomes -1, 3. My x stays the same, and now 0 plus 2 is 2. My y stays the same, now 1 plus 2 is 3. Okay, so now what I can do is this is important to remember, because I can either just shift, because we're only affecting the y. So my y means we're going up, right? So I can either shift all my points up 2, so 1, 2, and every point we're going to do this, okay? So I shifted it up 2, or I can come down here and I can just go, okay, -1, 3, 0, 2, 1, 3. And I can graph those. But what's important is we need to make sure that we're making a smooth curve, right? The graph needs to look just like the original. We don't want to put straight lines because that's a completely different graph. Okay, so super important here is that we are outside the grouping symbol, right? We're adding +2. Okay? Now, let's go to the next slide. So now we're going to do the same thing, but we're just going to shift our original function down, okay? So here is subtracting outside the grouping symbol. So we are still looking on the outside, right? Because this is the OG, right? Okay, so I am looking for the outside. Now my transformation rule, still affecting my y, right? But now I am just subtracting. Okay, so let's go to the next one. So my example, this is my parent function, right? So f of x equals the square root of x. Now I'm going to graph the transformation, okay? So -1, important, right? So I have my original, so my grouping symbol. Here, I'll do it in a different color. Here, let's just erase that. Okay. So I have, remember, my parentheses are really here. And then this -1 is outside of my grouping symbol, right? So this is affecting my y coordinate, okay? So here is my transformation rule. So this is my new transformation rule. Okay? So here we see that it's only affecting our y because it's outside the grouping symbol, right? So when I bring my new graph, this is the original, so OG. Ooh. Now, what I need to do is I'm going to make points again. So 0, 0. Look, I am choosing points, right, that are exactly on a coordinate. It's much easier than trying to find decimals and so on, okay? So my parent function, I'll do these in blue, is 0, 0, 1, 1, and then 4, 2, okay? Now, what I need to do is do a transformation function, right? So now I am going to subtract 1 from y. So my x stays the same, and 0 minus 1 is -1. So that's my new point. My next is my my x stays the same, y minus 1, so 1 minus 1 is 0. And then my last point, my 4 stays the same because it's my x, and 2 minus 1 is 1. I'm now going to go ahead and graph those. So 0, -1. So here what we could do is we could just move down 1. Or, like I said, we could point. So 1, 0, 4, 1. Then you're going to draw the same look-alike line, okay? So we want to draw the same shape of a line. So that's our vertical shift down, okay? Now, we are going to start moving. Now we're going to affect our x points, okay? Because now we're going to move left and right. All right? So now I have a horizontal shift right, okay? So what I'm looking for is I am looking for a subtraction sign inside the grouping symbol, okay? So this is important, inside. The last ones we looked outside, now we're looking for it inside, okay? So then I'm going to use my function notation. So this is what it would look like, okay? So we have it inside the grouping symbol, right? So we're looking for inside our parentheses because that's what grouping symbol means, okay? So my transformation rule. So now, last time we were affecting our y, now we're affecting our x. And notice, this is super important, that it's the opposite, okay? If we see a subtraction sign, we're really adding to our x, okay? Because our parent function is really like this, okay? So, but remember, if we have a positive number in here, it's going to be negative, right? And vice versa. If we have a negative number, it'll actually be positive because when we do this, a negative and a negative become a positive, okay? So when we're doing horizontal shifts, you're really doing the opposite of what's in the symbol, the opposite of the sign. So here, I have a parent function, right? So I have f of x equals the absolute value, okay? Now, my graphing transformation is x minus 2. So this negative 2 is inside the grouping symbol, right? Important, inside. Okay? And then now, we have to do the opposite. This is super, super important. If it says minus, we're doing addition. Okay? So this is my new transformation rule. So this is super, super important. Okay? You're doing the opposite. So I'll write it up here. Do the opposite. Okay, and I'll show you as we do that now. Okay, so here we have our graph. So the first thing on your original function, right, because this is my original function, is I'm going to pick 3 points, okay? So my parent function, because that's my original, is -1, 1. Sorry there. Okay, -1, 1, 0, 0, and 1, 1. This is just left to right. I pick points left to right. Now I'm going to do my transformation points, okay? So now it's affecting my x. So for every x value, I'm adding 2. So -1 plus 2 now becomes 1, and my y stays the same. Let me do this in a different color for you guys. Okay? So 1, 1. My y stays the same. Now I'm going to do the same thing with my next point. My x is being affected, so I'm going to do 0 plus 2. So 2, 0. And then on the last one, same thing. I'm adding 2 to my x. So, good. Okay, so now what we're going to do is we're going to shift our graph. Okay, so here, we can't just shift because it can get a little confusing. So what I want you to do is actually follow the points. So on my new, I'm going to go over 1, up 1. Okay, over 2, up none. Over 3, up 1. And then remember, we want our graph to look the same as the shape as the one that is originally there. Okay, so that's important. So see here, we just shifted to the right 2. So what we really did is you can move your points over 2, okay? So you can do that. But looking at these points is a little bit easier. Okay? So this was horizontal shift right. So now we're going to do horizontal shift left. So now, same thing, but instead we're having an adding inside our grouping symbol. Okay? So we're still inside that grouping symbol. Okay? Now function notation. So the only thing here we see that's different is plus h. Right? So remember, when we have plus, we're really doing the opposite. Okay, so same thing as last time. Do the opposite. Okay? So here, this is my new rule. So this is affecting my h, but remember, if it's addition, right, we're actually subtracting. All right, so same thing. Let's get our parent function. So this time our parent function is f of x equals x squared. Now we're going to graph our transformation. So here we see it's inside and it's a plus, right? So what we really need to do is minus. So this is our new transformation rule, okay? Transformation rule. So this is important. Remember, we got to make our points first. So I'm going to do the same thing here, here, and here. So now my parent function points are -1, 1, 0, 0, and 1, 1. Okay? So now we're going to pick our points. Remember, our x value is being affected, and we are subtracting 2. Even though it says plus, this means subtracting, okay? Means minus. Okay, so I'm going to make my new points. Now, my x is being affected. So I have -1 minus 2, which now becomes -3. Remember, my y does not get affected. Okay, same thing on the next. 0 minus 2 becomes -2. Y does not become affected. And lastly, 1 minus 2 is -1, and this 1 does not become affected. So now what I'm going to do is I'm going to plot my points. So I'm going to go over to -3 and up 1. okay? I'm going to go over to -2, up none. And then I'm going to go over to -1 and up 1, okay? So now, remember, smooth curve, okay? Looks just like our others. Now, what you could have seen is that we went over 2. We went over 2 and over 2. But I think this is easier to see, okay? Because it's going to bring you the right way. So major point on horizontal shift left and shift right is do the opposite of the sign. Do the opposite of what your intuition says to do, okay? Now, we are reflecting. So when we hear the word reflection, we think of a mirror, right? So it's a mirror image. So now this is, we are going to multiply by -1 outside the grouping symbol. Okay, so that's the important part here. Now, function notation. Here, you can see the negative. So that negative, we could pretend there's a 1 there, is outside of the original function. Okay? So my transformation rule. Here, because we're outside, it's affecting our y. So outside equals y, and inside equals x. So that's important to remember. Okay? So we are affecting our y. Okay? So now I'm going to give you an example. Parent function. So the apparent function we are using is f of x equals the square root of x. Then I'm going to graph my transformation. So now this is my new function. Now look here, outside of my grouping symbol. So we can pretend that there's parentheses here, right? My negative is outside the grouping symbol. Okay? So here's my new transformation rule. Okay, so affecting my y. Now we're going to graph. Same thing. Choose our points. Okay, choose our points. Choose our points. Super important. Okay, now I'm going to just write it down here. I know it's a little, I squeezed it. So my parent function points are 0, 0, 1, 1, and 4, 2. I know that could be a little hard to see. I'm sorry about that. I didn't leave enough room for myself, okay? So then I'm going to make my transformation function points. So now we are affecting our y. I'm sorry. So every y value, we're going to make it a negative. We're going to multiply by a -1. So obviously, that's going to stay the same because 0 times -0 is just going to be 0, right? We don't have a -0. Now I'm going to go to my next point. So my x is not affected, so it's going to stay as 1. Now we need to multiply my y by a -1. So 1 times -1 becomes -1. Same thing with my last point. 4, my x stays the same, and 2 times -1 is now -2. Okay? So that's important. Now we're going to graph our new points and see what happens. Okay, so 0, 0. So I'm going to graph that. Okay, and then I'm going to go over 1, down 1. Okay, and then over to +4 and down to -2. Now, we can draw this, right? But it's super, super, super important to know that these do not connect. This is a mirror image. It's a reflection, okay? When we see our reflection in the mirror, you're seeing the same thing, right? Just as a reflection. So we have to remember that these do not make one graph, right? It's just a reflection of each other, okay? So that's important to remember. These do not connect. Mirror image, remember that. So reflection, mirror, image, okay? All right, so now we're going to do the reflection over the y-axis, okay? Ooh. What happened? Oh, no. Here we go, okay. So I have a reflection over the y-axis, okay? So remember, mirror image. Now, what does this look like? Now, important, inside, okay? So remember, we're inside. So multiplying a -1 inside. Last one we were outside, now we're inside. Okay? So here you could see that. My -1 is inside my parentheses. Okay? Now my transformation rule. Now when we are reflecting over the y-axis, it means that we are affecting my x. Okay? So we're multiplying -1 to all of my x values. Okay, so my example, my parent function is the square root function. And here is my, what is now my transformation function, I'm sorry. So remember, oops, this one is inside, right? So we can think of this as inside. Now, because it's inside, we are changing or affecting our x points. Okay, so it's important to realize that if we're reflecting over our y-axis, we're changing our x points. And when we're reflecting over the x-axis, we're changing our y points. Okay, so here's my graph. So same thing. Pick my points, point, and point. So parent function, I'm sorry, I have to write it here again. 0, 0, 1, 1, 4, 2. Okay, so those are my parent function points. Now, I need to graph or take the transformation. So this is my transformation rule, right? So now we are going to change every x point, okay? So this is my transformation. And now my x is being multiplied by -1. So same thing, remember 0, 0, because you don't have a -0. Now we are multiplying this 1 times -1, which gives me -1, 1. And then I'm multiplying this by -1, so this becomes -4, 2. Okay, so these are my new points, so I'm going to go ahead and graph them. So boom, 0, 0, -1, 1, and then -4, 2. Okay, now if we look at this, it looks very similar to my original, right? But same thing, remember, this is a mirror image. These two functions that we just drew and graphed do not touch one another, right? It's just a mirror image. They're not a full line together, okay? So important, inside, we're multiplying by a -1, okay? All right, vertical stretch. Now this is a little different. So now these are going to make our graphs get tall, 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 okay? We're stretching them out. Like if you were to stretch out an elastic band, it grows, 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 grows. Okay, so what does it look like? So it's when I'm multiplying by a number greater than 1 outside of the grouping symbol. So what that means is any whole number, right? So anything bigger than 1. So really no fractions. So like whole number, no fractions. Okay, so that's important. That's all that this means. Okay, is we're just looking for whole numbers. Now my transformation rule. We are affecting our y because it's outside of the grouping symbol, right? Here you see it's outside the grouping symbol. So here we are multiplying whatever that number is out to y. So you'll see that in this example here. So I have my example and my parent function. So my original parent function is the absolute value, okay? Now we're going to get our graph transformation, okay? Here we see it's outside, right? Because those are parentheses. That's my grouping symbol, okay? So every y value, right, we're going to multiply by 2 because this is my new transformation rule, okay? So I'm here. Now I have my original function graph, okay? So same thing. Pick my points. My parent function. I'm going to pick this point. Nope, I lied. I'm going to pick this point, and this point. Okay, so I'm at -1, 1, 0, 0, and 1, 1. Now I need to transform, right? So I need to get my coordinates for my transformation function. So what my rule is I'm multiplying every y value by 2. So my x stays the same. So that -1 stays the same. And 1 times 2 is now 2. And then I go 0, 0, because 2 times 0 is just 0. And then I'm going to multiply my y here. My x stays the same, and 1 times 2 is 2. So now I'm going to go ahead and graph. So I have -1, 2, 0, 0, and then 1, 2. So what this does is it stretches it out and makes it skinnier and just skinnier, okay? So like you could just say skinnier and taller. So as we grow, we stretch out of our baby weight, right? So we get skinnier and taller. So you can see here that our graph got skinnier on both sides. okay? Now, the last one we're going to talk about is a vertical shrink, okay? So now this is going to stretch your graph out and make it fatter, okay? So think of when you eat so much and you're going to get a little shorter because you're going to get fatter, okay? So think about that when we see a shrink. Now, same thing. We're looking outside the grouping symbol, but this is important right here. This is a key thing that I need you guys to see. It's a fraction, okay? So it's not a whole number, okay? So here, this just means fraction. Okay, that's when you're gonna see that. What it's actually saying is when 0 is less than a, but a is less than 1. Okay, so that just means look for a fraction. Okay, and same thing, we're multiplying. Okay, so we're gonna multiply. So now we have, look, same thing. We're still affecting our y because we said that it is outside, right? And outside affects our y. Okay, so here we are at here, okay? We are affecting our y, okay? Now, my example. My parent function that I'm using is f of x equals x cubed. So this is a cubic function. So now, okay, it's gonna be a little difficult, but I don't want you guys to freak out, okay? So we are still inside, and the number we are using is 1/4, okay? So my new transformation rule is we are going to multiply our y by 1/4, okay? I know it could be a little difficult. You could use your calculators, no problem with me, but same thing. This is gonna be a little hard because as we get our points for our transformation, we're gonna get decimals. But how I want you to start off is with those points. So my parent function points are -1, -1, 0, 0, and 1, 1. Okay, so now we need to change our y's for our transformation function, okay? So this is important. We are multiplying every y value by -1, okay? We are multiplying every y value by 1/4. Okay, so our x value is gonna stay the same. And then -1 times 1/4 just becomes -1/4. Okay, and then the zeros stay the same because when you multiply anything by 0, it's 0. And then my x stays 1, and I'm multiplying my y to 1/4. So I'm just gonna keep it as 1/4. Now, this is where it can become a little tricky when you're graphing. I'm not going to be picky about it, okay? So just estimate. So I'm going to go -1, and I'll just say it's about here. So I'll say this point right here is about right here, okay? So that's important. Now, 0, 0 stays the same, and then I'm going to go up 1 and over about here. Okay, like I said, you just have to estimate, okay? And I'm going to try my best, like you're gonna try your best, to draw your graph somewhat similar to what that original looks like, okay? I'm not asking for a perfect art here, okay? But here, you see that your function, your transformation function, got fatter than the original, right? So that is everything you need to know about our function rules and our transformation and our shrinks and everything you need to know. Okay, so if you take anything away from this, I want to go back, is that when we have when you're adding, you're subtracting, you're multiplying outside the grouping symbol, it's affecting our y. So remember I said outside equals y, and inside, so anything that's happening inside the grouping symbol is affecting our x. Okay, that's super important to know. But that is our lesson for today. Super important watch. If you did not take notes, I would go back and take notes. Okay? Super important.